Yeah, this problem, you have given a list of words. Here you have 5 words. 1, 2, 3, 4, and 5. So these are from an alien dictionary. Though it uses English alphabets, their alphabetical order is not according to English alphabetical order. So you have to figure out the lexicographical order of their alphabets. If it is possible, you have to figure it out and return the string of alphabets by preserving the order of lexicographical order. If it is not possible, return an empty string. So how we analyze this problem? Suppose WRT and WRF. The WRT comes first, WRF comes second. So if you compare the positions, this is the first position, second position, third position. Same for here as well. So if you compare the positions, in the first position, W are there. So there is no conflict. We cannot identify any precedence from this. In the second position, R are coming. We cannot identify any precedence from that too. But in the third position, T and F are coming. T came in the first letter and F came in first word. F came in the second word. So obviously, T will have higher precedence than F, not it. T will come first, then F will come. When we compare, that is one thing. Now we can compare the second and the third. So the second word have 3 letters. Third word have only 2 letters. So we can compare only 2 letters, the lowest among them. So W and E. When we compare W and E, they are in the first position. But W is in the second word. E is in the third word. So W will have higher precedence. So W comes before E. W comes before E. And R and R are same letters. There is no conflict. Now let's go to third and fourth. Let's compare. E and E, there is no conflict. R and T, there is a conflict. R has to come before T. R has to come before T. When we compare fourth and fifth, E has to come before R. E has to come before R. T has to come before F. This relationship has already noted here. And T and T, there is no conflict. Now we can connect all these. W has to come before E. Let's keep it here only. R has to come before T. So before T, R has to come. This has used. Now E has to come before R. E has to come before R, used. Now W has to come before E. W has to come before E. W. Now we got a chain. This is a order of this is a possible lexicographical order. This is actually a correct lexicographical order. But we have to ensure all the characters mentioned among all these words have positioned in this chain of precedence. If not, we will have to discard it. If every character is available here, we can proceed with this map. This will be the order of precedence. So let's check what all characters are available. From first word, W, R, T are available. W, R, T are available. In the second word, W already is there, R is already there, F is there. F is a new word. And the third word, E is new word, R is already there. In the fourth word, E is there, T is there, T is there. Fifth, R is there, F is there, T and T is there. So in total, we have 5 letters. In the order in this precedential order chain, here also we have 5 letters. That means this from the given array of words, we can form a precedential order for the alphabets in this alien language. Now let's see how to code this. Before going to programming, let's have a discussion here itself how we proceed with this problem. So these are all links. This is one link, only this much. This is one link, this second link, third link, and fourth link. What we did is we assembled them topologically based on the ordering. So we have to identify these links. For that, we will have to create a graph. Once you create a graph, if you want to start exploring, how will you understand this is a graph? Because these are all links. Links means edges. So you have edges, your nodes will be your letters. So you can create a graph from this, and you can start exploring a breadth first search starting from a node where there are no incoming connections. So you need a adjacency list representing these links, and you need a record where you will be having where you will be having the degree of all the nodes. So this node has a degree 0, this has 1, 1, everywhere 1. So when you start exploring from this node, you can record your W. When you explore this one, you can release its degree and make it 0. Then you can explore that one. So W, E will come. Then you will explore the third one. R will come. Explore the fourth one. T will come. Explore the fifth one. F will come. So this string, you can return it as an answer. So you have to make a adjacency list of links by comparing the words next to next words, sequentially consecutive words. Then you need a in degree record so that you can do a kind of breadth first search and understand and create and form a answer string or character vector, which is basically a string of this alien alphabets of this alien language. So now let's see the code. You need a in degree. This will check this is for degree. And only for, let's make it set. This is your grid or graph. Now you have to form the graph. For that, just define the size of word list. At a time, you need 2 words to compare. W1 equal to it's a I string. W2 equal to it's a I plus. So now you have 2 of your words. Start comparing. You have to get a length which is minimum of W1 dot size and W2 dot size. Iterate over this length. And J plus plus. And those characters are not equal. W1 of J not equal to W1 of W2 of J. If those characters are not equal, then engue them into your grid of which one will be connecting to which one. Your first word W1J dot insert and W2 of J, and increase the degree of W2 J. So this will give you, and one thing you have to do is you have to initialize the degree of all characters as 0. That is mandatory, because then only you will be able to identify words with characters which are 0 in degree. For JS, so I dot size J plus plus C grid of words of I comma J. What is the degree? Set 0. It is degree. Now you have your degree set, and you have your graph. Now start exploring your result, the lexicographical ordering. You need a queue for doing breadth first search, which will have character. What it will have? It will have character queue. Engue the character required. Engue all the characters which are required. So how will you go with that? Auto IT degree. If it dot second equal to 0, q dot push it dot first. While negation of q dot size, take the element from the front of the queue. How will you pull that out? It will be a character q dot front. Now q dot pop. Add that character to your result. Explore that character further. All the characters which are neighboring to this one. So create of C. Now what you have to do? If decrement the in degree and degree of x minus. If degree of x equal to 0, q8. Q dot push, what you have to push? Q dot push x, because you have to explore that. Finally, check your s dot size equal to degree dot size. If they are equivalent, return result or return degree or return null, because they are equivalent when all the characters in the language is present in your lexicographically ordered string, in the alphabet string. If all of them are present, you can confidently return that as a solution. Otherwise, you have to return a null. Let's test the solution. It's giving null. So there is something wrong with this word of ij. They are all correct only. Let's try printing what's happening here. It's reaching nowhere. It's not coming inside. Q dot empty. It's correct. Yeah, WERT. Is it this WERT? WERT. What was our solution? WERT, yeah. Okay, there is something wrong. It's giving null. So WERT it is reaching. So what could be the issue? These two are not equal. Means demo dot size. This in degree is corrected. Degree initialization. Every bird we will take, and every character in that bird we will take and initialize into 0. Even that is correct only. What is n? N is size. We have less than n minus 1, means it will be n minus 2 and it will become n minus 1. I is correct only. String is result, and you need a character over here. Q not empty, that's correct. In the grid, you are checking your current character and you are getting its neighbor, releasing its degree. If the degree is 0, you will be pushing it inside. Doing with some kind of vector. Will that help? No, that won't. Less likely it help. That won't help. So what's the problem now? You are not getting F. W1. Let's print these relations. W1 of J, W1 of J. Next, W2 of J. TF, WE, RT, again TF. Okay, here you might require that condition. If rid of W1, J dot find W2 of J equivalent to 10, then only you do this operation. That was a fix required. Thanks for this comment. So WERTF, that's the answer we created here. WERTF. Thanks for listening.